All right, so we're going to be investigating today something called the triangle inequality theorem. And what the triangle inequality theorem proves, it proves if three different side lengths can make a triangle. So I've got some kind of tools for us to use today to investigate on whether or not we can form a triangle from these lengths. And the way that this works is I have my one side here at the bottom, and I have my two sides kind of pointing up like a goalpost right now, right? Because we know that triangles have three sides, and that's why I've got three pieces right here. So what I'm going to do is I'm going to take these arms and I'm going to fold them until they meet in the middle. And if it makes a triangle, I should be able to pop them together so I form a complete triangle just like this. So here's our example of a triangle. And specifically, when I look at this triangle, I notice that all three of them are yellow, which means with these tools that all three of them are the same size, the same length. So this triangle right here is called an equilateral triangle. All three sides are the same. Again, it forms a triangle. I can snap them together, and we have a triangle. But let's try some other ones. Okay, so this time I notice that all three of my sides are different lengths. So if this forms a triangle, this is going to form what we call a scalene triangle. All three sides are different. So again, I'm going to take my arms here. I'm just going to move them until I am able to snap them together. Sure enough, we have another triangle. Again, all three of them are different. Scalene triangle. Let's try another one. All right, again, I've got three different colors. So if this forms a triangle, this should be a scalene triangle. I've got my two arms right here. So let's take those arms. Let's move them. And it looks like these will snap together to form a triangle as well. Looking at our next one. Again, I've got three different colors. So if this snaps together, this will be a scalene triangle. I'm going to take my arms, I'm going to move them, but they're just never going to meet. So this does not form a triangle at all. No matter what I do, I can't get that orange and purple to snap together. So this does not form a triangle. So I'm going to move those arms back down. And one of the things, I'm going to show us our other triangles, and I want to see what we notice with these triangles. So again, this top one right here does not make a triangle. Let's go back to our scalene triangle with the blue, the orange, and the yellow. I'm going to snap my two arms so they can move. Again, I'm going to fold till I have that straight line. I'm going to do the same thing with my other one that formed a triangle. So my green and purple. And again, I'm going to fold until they make that straight line. So there's one big difference. Again, this one does not make a triangle, but these two do. So what I want to see here is right now, when I look at this line that I've created, I can see all three colors. I see purple, red, and orange. But on my two that make a triangle, I can only see two of the colors. I can only see the yellow and the orange. The blue is totally hidden. And on this one, I can only see the green and the purple. The blue is totally hidden. So what I'm looking at is my arms have to be, when I take them all apart and lay them next to each other, my two arms have to be longer than that third side. And so when I look at my one that's not a triangle, that orange and purple, it's close, but it is not longer than that red third side. So that is our triangle inequality theorem. It states, and I'm going to zoom back in, so sorry for my pterodactyl. It states that the sum, which means we're adding, of the lengths of the two shorter sides have to be greater than the length of the longest side. So that's what we were showing here. I'll move it here. That's what we were showing here is I have my purple and my orange. It's longer than the yellow, so this should make a triangle. But if I had two oranges and a blue, That's not longer than the blue one, so this would not make a triangle. So they use a inequality to prove this theorem, okay? And we're going to use variables for this. Remember, variables are just letters that are representing unknown numbers, but the variables that are used are A and B. So A plus B for the shorter side has to be greater than the longest side, which we call C. So A plus B has to be greater than C. So let's look at a few examples. Example 1 says, will lengths of 3 centimeters, 6 centimeters, and 4 centimeters form a triangle? So I'm looking for my two shortest sides, which are 3 and 4. So if I follow this theorem, 3 plus 4 has to be greater than my longest side, which is 6, in order for this to be a triangle. 3 plus 4 is 7. 7 is greater than 6. This is a true statement. So yes, this would make a triangle. Our next one, will lengths of 2 centimeters, 4 centimeters, and 2 centimeters make a triangle? Again, you're looking for your smallest sides, those shortest sides. So 2 and 2 are my shortest sides. So if I follow my theorem, A plus B is greater than C. So 2 plus 2 is 4. Greater than 4? Well, 4 is not greater than 4. 4 is equal to 4. So this statement right here, it's not true. So no, this will not form a triangle. Our next one, we have, will lengths of 6 centimeters, 2 centimeters, and 3 centimeters form a triangle? My two shortest sides are 2 and 3. So following my theorem, it should be 2 plus 3 is greater than 6, which is my longest side. 2 plus 3 is 5, is greater than 6. 5 is not greater than 6. This is a false statement, so this will not make a triangle.